December 7, 1941. The morning sky over Pearl Harbor belonged to a machine the Americans didn't believe could exist. Lieutenant Commander Shigeru Itaya banked his Mitsubishi A6M into a climbing turn, sunlight flashing off the polished cowling as Oahu's green mountains fell away beneath him. Below, the harbor was already a hell of smoke and flame battleships listing. Oil fires spreading across water turned black and orange. But Itaya's mind was on the sky. He'd spotted a pair of Curtiss P-36 Hawks clawing for altitude, American pilots scrambling to meet the attack. The textbook said this was supposed to be a fight. The textbook was wrong. The Zero closed the distance with shocking speed. Itaya barely touched the stick. The aircraft responded like thought-made aluminum, rolling into firing position with a lightness that felt almost eerie. The P-36 tried to evade, but it was like watching a man run through water while Itaya moved through air. A 2-second burst from the twin 20mm cannon in the wings. The American fighter came apart, pieces tumbling through the smoke. The second P-36 dove hard, trying to use speed and gravity to escape. The Zero followed, effortless, and carved it from the sky before the pilot could react. This was not how aerial combat was supposed to work. Not according to Western experts, not according to the intelligence briefs that had dismissed Japanese aviation as derivative and second-rate. Itaya and the men flying beside him were proving every assumption wrong, one smoking wreck at a time. By the time the second wave withdrew, the Zero had announced itself to the world in the most brutal way imaginable. Complete aerial dominance. Over Pearl Harbor, over the Philippines, over Malaya and the Dutch East Indies, wherever Japanese forces struck in those first devastating weeks, the Zero appeared like a curse. It turned inside Allied fighters that couldn't match its agility. It climbed away from attacks that should have caught it. It stayed in fights long after it should have run out of fuel. Pilots who survived encounters described it in tones of disbelief. Too fast, too nimble, too lethal. The shock wasn't just tactical, it was psychological and strategic. For decades, Western military thought had operated on a comfortable assumption that Japan, for all its industrial progress, remained technologically behind. Japanese manufacturing was seen as imitative, their designs derivative, their engineers clever copycats but not true innovators. The idea that Japan could produce a fighter superior to anything America or Britain fielded seemed impossible. It violated the racial and cultural presumptions baked into military intelligence of the era. But the Zero was real. And in early 1942, it was wiping Allied air power from the Pacific sky. The aircraft that would become the A6M Zero began not with engineers, but with a prophecy of war. In 1937, the Imperial Japanese Navy issued a specification so demanding it seemed almost fantastical. They wanted a carrier-based fighter with a maximum speed over 500 kilometers per hour, a climb rate that could reach 3,000 meters in 3.5 minutes endurance for over 2 hours with drop tanks and most critically maneuverability superior to anything currently flying. Oh, and it had to carry 2 20mm cannon and 2 7.7mm machine guns. Most manufacturers looked at the requirements and declined to bid. The numbers didn't add up. You could build a fast fighter or a maneuverable one, not both. You could have range or you could have firepower, but the weight penalty made having both impossible. The Navy was asking for an aircraft that defied the fundamental trade-offs of aeronautical engineering. Mitsubishi's chief designer, Jiro Horikoshi, looked at the same requirements and saw a challenge worth accepting. He was 34 years old, brilliant, and willing to make radical choices that more conservative designers wouldn't dare. If the Navy wanted the impossible, he would give them the impossible, but at a cost they didn't yet understand. Horikoshi's solution was elegant and dangerous. Strip away everything that wasn't essential to performance. The Zero would have no armor plate protecting the pilot. No self-sealing fuel tanks that could survive bullet strikes without exploding. The airframe would be built as light as physically possible, using a new aluminum alloy that was strong but thin. Every gram of unnecessary weight was shed, every component refined to the edge of failure tolerance. The result was an aircraft that weighed barely 1,680 kilograms. Empty, extraordinarily light for a fighter of its era. That lightness, combined with a 950 horsepower Nakajima Sake radial engine and careful aerodynamic design, gave the Zero performance that seemed supernatural. It could outturn virtually any opponent. Its power-to-weight ratio allowed climbs that left Allied pilots gaping. And those drop tanks gave it a combat radius of over 1,000 miles, unheard of for a carrier fighter, allowing it to range deep into enemy territory and still return home. But Horikoshi knew what he'd sacrificed. The Zero was a glass sword, devastating in skilled hands but fragile. A few hits from heavy machine guns could cripple it. Fire was a constant danger, fuel tanks rupturing and igniting with horrifying ease. The aircraft demanded absolute mastery from its pilot because any mistake, any moment of inattention, could be instantly fatal. The Navy accepted these trade-offs eagerly. Japanese naval aviation doctrine prioritized offense over defense, skill over survivability. Their pilots were trained to an extraordinary standard, hundreds of hours, rigorous selection, an elite culture that valued perfection. The assumption was that superior pilots and superior aircraft wouldn't get hit. And in 1941, for a terrifying year and a half, that assumption held. The Zero entered service in July 1940, first seeing combat over China. Chinese pilots, flying Soviet-supplied I-15 and I-16 fighters, were slaughtered. The Zero's advantages were so overwhelming that within weeks, Chinese air opposition in certain sectors simply ceased. Pilots refused to take off when Zeros were reported overhead. Japanese aviators began racking up kill scores that would have seemed like propaganda if they were independently verified. The Navy watched with satisfaction. They had their weapon. But beyond the kill ratios and the tactical victories, something more subtle was happening. The Zero was reshaping Japanese naval strategy. Its range meant carrier task forces could strike from distances previously considered safe. Its dominance meant amphibious landings could proceed without fear of air attack. The entire operational calculus of the Pacific War would be written around what the Zero could and couldn't do, and in 1941, the list of things it couldn't do was very short. When Pearl Harbor came, the Zero wasn't a secret. American intelligence had reports of a new Japanese fighter, some details from China, grainy photographs. But the reports were fragmentary, often dismissed, buried under the weight of institutional assumptions. Even when the evidence was clear, it was filtered through a lens of disbelief. How could Japan, a nation that still relied on Western machine tools and imported technology, suddenly leapfrog ahead? The answer to that question, how Japan built the Zero, reveals a story more complex than simple innovation. It's a story about strategic choices, cultural priorities, and the consequences of optimizing for a specific kind of war. Jiro Horikoshi was not working in isolation. He was part of a Japanese aviation industry that had grown with startling speed in the 1930s, fueled by military demand and access to foreign expertise. Japanese engineers studied at MIT and Caltech, toured European factories, purchased licenses for engines and designs, and then adapted what they learned with meticulous care. The Nakahajima Sake engine that powered the Zero was derived from American designs, but refined through thousands of hours of testing. The 20mm cannon were license-built Swiss Oerlikon weapons, modified for aircraft use. But the Zero's design philosophy was uniquely Japanese, shaped by doctrine and geography. Japan's war plans assumed conflict across vast oceanic distances, where range was survival. They anticipated fighting numerically superior, but qualitatively inferior opponents, Chinese pilots, colonial defenders, enemies who could be beaten through superior skill and equipment. The Zero was optimized for that vision of war. Horikoshi achieved the impossible lightness through obsessive attention to detail. The Zero's wing spars were made from a single piece of extruded aluminum alloy, lighter and stronger than riveted construction. The control surfaces were fabric-covered to save weight. Even the radio was stripped out of early models because it weighed too much and pilots claimed they didn't need it. Every fastener, every component, was examined and refined. The lack of armor and self-sealing tanks wasn't an oversight, it was a conscious choice. Horikoshi knew that armor and fuel protection added hundreds of pounds. That weight would cost speed, climb rate, range, and maneuverability. The Navy's doctrine held that the best defense was not getting hit, and the best way to not get hit was to outfly the enemy. In a dogfight, the Zero's agility meant it could force the fight into turning engagements where heavier, less maneuverable opponents were helpless. And it worked. In the first 6 months after Pearl Harbor, the Zero's kill-to-loss ratio was staggering. Estimates range from 10-1 to as high as 20-1 in some theaters. Allied pilots developed a near-superstitious dread. Intelligence reports from early 1942 describe Allied aviators refusing to engage when outnumbered, breaking off attacks when Zeros appeared, sometimes jettisoning bombs and fleeing at the first sight of the distinctive silhouette. The psychological impact was immense. American, British, Dutch, and Australian pilots, many of them flying obsolete aircraft like the Brewster Buffalo or undergunned P-40, Warhawks, found themselves comprehensively outclassed. The Buffalo, in particular, was a death trap against Zeros. Over Malaya and Singapore, entire squadrons were wiped out. Pilots who bailed out and survived told stories of Zeros toying with them, making multiple passes, the Japanese pilots clearly demonstrating superiority before delivering the kill. This wasn't just about the aircraft, it was about the men flying them. Japanese naval aviators in 1941 were among the best-trained pilots in the world. Many had combat experience from China. Training was brutal, attrition was high, and only the most skilled made it to carrier squadrons. These men knew their aircraft intimately, understood its limits, and could exploit its strengths with precision. They fought with a tactical aggression that shocked their opponents' head-on attacks. Diving from above with the sun behind them, coordinated team tactics where wingmen covered each other with ruthless efficiency. But there were cracks in the system, visible even in victory. The Zero's fragility meant that even when Japanese pilots won, they sometimes didn't come home. A lucky burst of defensive fire, a single tracer into the fuel tank, and the Zero became a fireball. And unlike the Americans, who were already building training pipelines to replace losses, Japan's system couldn't scale. The emphasis on elite quality meant that when experienced pilots were lost, they couldn't be easily replaced. Moreover, the Zero's dominance created its own strategic problem. It allowed Japanese leaders to believe their initial assumptions were correct, that qualitative superiority would always trump numbers. The carrier raids, the rapid conquests, all seemed to validate the pre-war planning. But those victories were setting up a reckoning. Every month of dominance gave the Allies more time to study the Zero, understand its weaknesses, and develop counters. The first real intelligence breakthrough came in July 1942, when a Zero crashed in the Aleutian Islands with relatively minor damage. The pilot, Tadayoshi Koga, had been killed on impact, but the aircraft was intact. American forces recovered it, shipped it to Naval Air Station North Island in San Diego, and proceeded to test fly it exhaustively. What they learned was both reassuring and troubling. The Zero was indeed extraordinarily maneuverable and could outturn anything the U's had, but it had weaknesses. Above 200 knots, the controls stiffened dramatically. The light construction that gave it agility at low speeds made it sluggish at high speeds. It couldn't dive as fast as American fighters without risking structural failure. And the lack of armor meant it was vulnerable to even moderate damage. Armed with this knowledge, American tacticians began developing counters. The answer wasn't to outturn the Zero, that was suicide. Instead, it was to refuse the turning fight entirely. Use speed and altitude. Attack from above, make one high-speed pass, and then extend away before the Zero could bring its maneuverability to bear. Don't dogfight, boom, and zoom. Hit and run. And when you did hit, even a short burst could be catastrophic for the fragile Japanese fighter. This doctrine, formalized as the Thach Weave and other tactics, began spreading through U.S. fighter squadrons in mid-1942. It wasn't a magic bullet. Many pilots still died trying to turn with Zero's muscle memory and instinct overriding training. But gradually, the kill ratios began to shift. The Battle of Midway in June 1942 marked the beginning of the end of the Zero's supremacy, though not in the way most people think. Midway is remembered for the sinking of 4 Japanese carriers, a catastrophic loss of flat tops that shifted the naval balance in the Pacific. But equally devastating was the loss of aircrew. Experienced Zero pilots went down with their ships or were shot down during the battle. Japanese carriers before Midway operated with roughly 100 aircrew per ship, pilots, observers, gunners. After Midway, Japan had lost not just the carriers but hundreds of irreplaceable veterans. The Japanese training system couldn't absorb that kind of loss. Pre-war, pilots went through 700+ hours of training. By late 1942, that was being cut. By 1943, new pilots were arriving at frontline units with barely 100 hours. They were brave, dedicated, and nowhere near ready to exploit the Zero's strengths or compensate for its weaknesses. A novice pilot in a Zero was just a target in an unarmored aircraft. Meanwhile, American industrial capacity was flooding the Pacific with new fighters. The F-6F Hellcat, designed specifically with lessons learned from captured Zeros, began arriving in early 1943. It was faster than the Zero, could dive away from trouble, and was rugged enough to absorb punishment and bring pilots home. It couldn't turn with a Zero, but it didn't have to. Hellcat pilots used altitude, speed, and teamwork to dictate engagements, forcing fights the Zero couldn't win. The F-4U Corsair, with its massive 2,000 horsepower engine, was even more brutal. In the hands of Marine pilots like Gregory "Pappy" Boynton and his Black Sheep Squadron, the Corsair became a Zero killer, using sheer speed and power to overwhelm opponents. The P-38 Lightning, with its twin engines and concentrated nose armament, offered heavy firepower and the ability to keep fighting even with one engine damaged, a survivability the Zero could never match. But technology alone doesn't tell the full story. What changed was doctrine and experience. By 1943, American pilots understood the Zero. They knew its strengths and respected them, but they also knew its limits. Tactics were refined and disseminated. Newer pilots were drilled relentlessly. Never turn with a Zero. Use your speed, fight as a team. The mystique was gone, replaced by cold tactical calculation. Japanese pilots, even the skilled ones who remained, found themselves increasingly on the defensive. Fuel shortages limited training hours. The loss of forward bases meant Zeros were often operating at the edge of their range, with no margin for extended combat. And as the Allied advance continued, Japanese air groups were ground down through attrition, not decisive battles. But the slow bleed of daily combat where losses slightly exceeded replacements, month after month. The Zero itself was evolving, but not fast enough. The A6M3 and A6M5 variants introduced minor improvements, better engines, some structural reinforcement, occasionally a small amount of armor, but these were incremental. The fundamental design remained unchanged because the Japanese aviation industry lacked the capacity to develop and mass-produce a true replacement. Projects like the J-2M Raiden and the N-1KJ Shiden showed promise, but production was delayed, plagued by engine problems and bombing of factories. By 1944, the Zero was obsolete. Allied fighters were faster, better armed, and flown by pilots who had learned how to fight. The kill ratios reversed. Hellcats and Corsairs were shooting down Zeros at rates of 10 to 1 or higher. The same ratios the Zero had enjoyed 2 years earlier now turned against it. The most poignant evidence of the Zero's decline came during the Marianas Campaign, June 1944. Japanese naval aviation launched a massive strike against the U.S. fleet over 400 aircraft, including hundreds of Zeros. American carrier fighters, guided by radar and directed by fighter controllers, intercepted the raids far from the fleet. What followed became known as the Great Marianas Turkey Shoot. In a single day, American pilots shot down over 300 Japanese aircraft. The Zero, once the terror of the Pacific, was being swatted from the sky in wholesale numbers. The pilots flying those Zeros were mostly teenagers with minimal training, thrown into combat in aircraft that required expertise they didn't have. They flew bravely into formations of Hellcats and died without scoring significant hits. It was slaughter, and it marked the effective end of Japanese carrier aviation as a fighting force. In the final year of the war, Zeros that survived were increasingly used for kamikaze attacks. The logic was brutal. If the aircraft and pilot were going to be lost anyway, at least ensure that loss inflicted damage. Zeros stripped of guns and loaded with explosives dove into American ships, the ultimate expression of the design's fragility turned into a weapon. Young pilots, some with less than 50 hours of flight time, took off knowing they wouldn't return. The Zero, designed for agility and grace, became a guided missile in the hands of the desperate. There's a photograph taken sometime in late 1945 on a captured Japanese airfield. A line of Zeros, perhaps 24, sit in neat rows. They're intact but abandoned, propellers still, canopies open to the tropical rain. Rust already stains the aluminum. American soldiers stand nearby, casually, some smoking, one leaning against a wing. The aircraft that once ruled the Pacific sky are now curiosities, relics, already fading into history. The Zero's story is a tragedy of optimization. It was a brilliant answer to a very specific question. How do you build a carrier fighter that can dominate in 1941? And for a brief, terrible window, it was perfect. But it was optimized for a kind of war that didn't last a war, where quality could overcome quantity, where elite pilots and superior machines could hold off numerically greater forces, where Japan's limited industrial base wouldn't matter because the war would be short and decisive. None of those assumptions held. The war wasn't short. American industry buried Japan under an avalanche of steel carriers, aircraft, fuel, ammunition, everything needed to sustain a grinding campaign of attrition. And attrition was the one kind of war the Zero couldn't win. Jiro Horikoshi survived the war. In later interviews, he spoke about the Zero with a mix of pride and sorrow. He was proud of the engineering achievement, the elegance of the design, the fact that his aircraft had done exactly what it was meant to do. But he was also haunted by what it had been used for, the lives lost on both sides, the kamikazes. He spent the rest of his life designing civilian aircraft, trying to build things that didn't kill. The Zero's legacy is complex. In purely technical terms, it was a masterpiece, an aircraft that stretched the boundaries of what was possible with the materials and knowledge available in 1940. It influenced fighter design worldwide. After the war, American and British engineers studied recovered Zeros carefully, learning from Horikoshi's weight-saving techniques and aerodynamic refinements. But the Zero also taught a harder lesson about the limits of tactical brilliance. You can build the best weapon in the world, but if your strategic situation is unsustainable, if your opponent can outproduce and outlast you, then technical superiority becomes irrelevant. The Zero dominated until it didn't, and when that moment came, there was no recovery. Japan lacked the industrial depth to replace it with something better, lacked the fuel to train enough pilots, lacked the time to adapt. The contrast with American aviation development is stark. The US entered the war with fighters that were, frankly, mediocre. The P-40 was outclassed, the F-4F Wildcat was a decent but unspectacular carrier fighter. The P-39 and P-400 were failures in most roles. But American industry and design bureaus could iterate rapidly. When the Zero revealed weaknesses in US aircraft, new designs were on the drawing board within months. The Hellcat went from concept to combat in under 2 years. Production scaled to thousands per month. Japan couldn't do that. The Zero stayed in production until the war's end, not because it was still the best option, but because there wasn't the capacity to build enough of anything else. Factories were bombed, materials were scarce, skilled workers were drafted. The aviation industry that had produced the Zero in 1940 was a shadow of itself by 1945. There is a counterfactual question that haunts discussions of the Zero. What if it had been given armor and self-sealing tanks from the beginning? Would that have changed the outcome? The answer is almost certainly no. The armor and protection would have reduced performance, making it less dominant in 1941-42, and by 1943, it wouldn't have mattered Allied fighters were good enough that the Zero, armored or not, would have been outmatched. The fragility bought Japan a year of supremacy, which was all the design could ever offer. For the pilots who flew against it and survived, the Zero left an indelible mark. American and Allied aviators who fought in the Pacific developed a respect for the aircraft that bordered on awe, mixed with relief that they'd learned to counter it before it was too late. Many kept photographs, pieces of wreckage, memories of the fighter that had seemed invincible. For Japanese pilots who survived the war, the Zero was both symbol and ghost. It represented a moment when Japan had stood as a technological equal, when the quality of their training and equipment had seemed sufficient. But it also represented the futility of that moment, how quickly dominance had evaporated, how the war they thought they could win had turned into a nightmare of attrition and defeat. In the decades since, the Zero has been mythologized, turned into a symbol of Japanese ingenuity and tragedy. It appears in films, anime, museums. Restored Zeros fly at air shows, their engines growling, a living connection to a vanished era. Audiences watch them and see different things. Some see elegance and engineering brilliance. Others see the kamikazes. Still others see the complexity of a war that was never as simple as the movies suggest. The truth is the Zero was all of those things. It was a beautiful aircraft that shocked the world, dominated the sky, and then burned. It was a weapon built on choices to prioritize agility over protection, offense over defense, quality over quantity. Those choices made sense in 1940. By 1945, they'd led to catastrophe. Standing on that abandoned airfield in 1945, looking at those silent Zeros rusting in the rain, you could see the entire arc of the Pacific War. The ambition, the brilliance, the hubris, the inevitable collapse when reality met hope. The zero had shocked the world. But the world learned, adapted, and moved on. The shock faded. The lessons remained. If this exploration of innovation, adaptation, and the cost of strategic miscalculation resonates with you, subscribe. History's greatest weapons often reveal the most about the men who built them and the wars that consumed them.